In the last lecture, we learnt about the concept of differentiation. If you haven't seen, do see that video. Link is on the screen and in the description. Today, we'll understand the practical aspect with the way to solve differentiation problems using the various rules of differentiation. आपको इसमें क्वेश्चंस जनरली इस तरीके से आते हैं कि एक फंक्शन इज गिवन and you have to find its derivative. Like a function could be y is equal to x square plus 3. Y is equal to x square plus 3. You have to find its derivative dy by dx. Now, how to find the derivative is what we are going to learn today. We will start with some simple rules and add on to them in the later lectures. Chalo. Rule 1 is derivative of a power function. If y is equal to x to the power n, if y is equal to x to the power n is a function given to us, then dy by dx, that is the derivative of this particular function, can be written as n into x to the power n minus 1. क्या किया हमने? The n which is given in the power, we bring that down here as the coefficient and then reduce the power by 1. So n becomes n minus 1 in the power and the result is the derivative that we get. For example, एक क्वेश्चन करके देखते हैं. Y is equal to x cube. The derivative of this function using this rule is, first of all, how do we denote the derivative of a function? D by dx of the function. ठीक है, d by dx of the function. So on the LHS, we get d by dx of y, which is written as dy by dx. And on RHS, using the power rule, this 3 comes down as a coefficient and the new power becomes 3 minus 1 is equal to 2. So you get dy by dx is equal to 3x square. Simple. See one more example. Y is equal to x to the power 1 by 4. Y is equal to x to the power 1 by 4. Therefore, derivative of this function is dy by dx, and on the right hand side we get 1 by 4 as the coefficient, the power comes down as the coefficient, and the new power becomes 1 by 4 minus 1, which is 1 by 4 minus 1 can be written as 1 minus 4 by 4 is equal to minus 3 by 4. So your right hand side becomes 1 by 4 as the coefficient into the power minus 3 by 4. Simple. Let's see the next rule. Rule number 2. Derivative of a constant. Simple hai. Derivative of a constant is 0. So if you have a constant function like y is equal to c, then dy by dx is equal to 0. इसको डिराइव कैसे किया है? वैसे तो you can just simply remember the rule, derivative of a constant is 0, but if you see here, y is equal to c, can we write this as y is equal to c into x to the power 0? Because x to the power 0 is 1. Any variable to the power 0 is 1. So we are writing y is equal to c as y is equal to c into x to the power 0. Now when we do the derivation of this x to the power 0, 0 will come as the coefficient. So it means the entire value on the right hand side will become 0. For example, y is equal to 5. So the derivative of this function is dy by dx is equal to 0. Next rule. Rule number 3. Derivative of a function having a constant multiplier. The previous rule was having a constant, derivative of a constant. Here we don't have a constant alone, we have a constant multiplier. So if we have y is equal to k, which is a constant, into x to the power n, then its derivative is dy by dx is equal to k as it is. So this constant multiplier comes as it is, and x to the power n differentiate हो जाएगा using rule 1, that is n into x to the power n minus 1. So your full derivative comes out as dy by dx is equal to k into n into x to the power n minus 1. See, यहाँ पर k is a constant, but here this constant is a multiplier to the variable x. Therefore, here k will not become 0. Here you cannot use rule 2 that was derivative of a constant. Instead, the constant multiplier is retained as it is and the variable part is differentiated using rule 1. Clear है? इसका एक एग्जाम्पल देखो. A function y is equal to 7x cube. Y is equal to 7x cube. Find dy by dx. We get dy by dx is equal to 7. So this constant comes as it is into. Now we'll just do the differentiation of x cube. So it becomes 3 into x to the power 3 minus 1. This becomes dy by dx is equal to 7 into 3, 21. So 21x square. Let's see the next rule. Rule number 4, extended power function. This rule is basically an extension of rule number 1, power rule. It also uses rules 2 and 3, that is the rule for derivative of constant and that of the constant multiplier. Suppose you have a function y is equal to ax plus b whole of this to the power n. Here if you see, only the independent variable x doesn't have a power, but an entire algebraic equation of x has the power n. इस पूरी इक्वेशन की पावर n है, only the variable part x की पावर n नहीं है. So the rule says n comes down here as the coefficient of the equation, the whole equation, it becomes n into ax plus b to the power n minus 1. यहाँ तक it is a replica of the rule 1. Further, this is multiplied by a and your full derivative becomes n into ax plus b to the power n minus 1 into a. Now look carefully, what does the rule say? First, treat the entire equation that has the power as a single variable. Differentiate it as if it is a single variable with power. Therefore you get n into ax plus b raised to the power n minus 1. जैसे हमने एक पर्टिकुलर वेरिएबल होता है एक्स क्यूब या एक्स टू द पावर 4. सो जस्ट लाइक दैट ट्रीट दिस एंटायर पार्ट ए एक्स प्लस बी, दिस एंटायर इक्वेशन एज अ सिंगल वेरिएबल और इस पे रूल 1 अप्लाई करो. सो द कोफिशिएंट कम्स हेयर n and what you get is ax plus b power n minus 1. Then in the next step, whatever is in the bracket, that is the algebraic equation, differentiate it using rule 1 or 2 or 3, whatever be the case. Now find the derivative of ax plus b. Can we write this as ax to the power 1 plus b? Ax plus b ko we can write ax to the power 1 plus b. X to the power 1 is x only, right? Derivative of ax to the power 1 using rule 3 is a. And derivative of constant b is 0. So the derivative of ax plus b is a. That is why your complete derivative becomes n into ax plus b to the power n minus 1 into a. This into a is basically the differentiation of this equation part ax plus b. Let's see some examples to make it clearer. If y is equal to 2x minus 5 whole cube, what is dy by dx? Now dy by dx is equal to 3 into 2x minus 5 raised to the power 3 minus 1 is equal to 2 into 2. This 2 in the end is the derivative of 2x minus 5. So our answer can be written as 3 into 2 is equal to 6 into 2x minus 5 whole square. Easy? See another one. Y is equal to 3 by 2x minus 3, this whole thing raised to the power 1 by 2. कैसे करेंगे इसको? dy by dx is equal to 1 by 2, ये पावर इधर कोफिशिएंट में आ गई, into 3 by 2x minus 3 raised to the power minus 1 by 2. Minus 1 by 2 क्यों आया? Because the earlier power was 1 by 2. So when we do the differentiation, it becomes power minus 1, n minus 1. So it is 1 by 2 minus 1, and 1 by 2 minus 1 is minus 1 by 2 into 3 by 2x minus 3 का differentiation क्या आएगा? 3 by 2. 3 का differentiation, 3 is a constant, is 0. 3 by 2x का is 3 by 2. So what we get is 3 by 4, this 1 by 2 into 3 by 2, 3 by 4 into 1 divided by under root of 3 by 2x minus 3. Because हमारे पास न्यूमरेटर में था 3 by 2x minus 3 raised to the power minus 1 by 2. नेगेटिव वैल्यू को if we take down in the denominator, so power change हो जाएगी 1 by 2, and 1 by 2 means under root. So that is why we reframe the answer as 3 by 4 into 1 divided by under root of 3 by 2x minus 3. Simple. चलो एक और देखो. y is equal to under root of 2x minus 1. y is equal to under root of 2x minus 1. Now 2x minus 1 can be written as 2x minus 1 whole raised to the power of 1 by 2. Now the rest of it can be solved in the same way as we did the previous one. dy by dx is equal to 1 by 2 into 2x minus 1 raised to the power minus 1 by 2 into 2. Why into 2? Because this 2 is the derivative of 2x minus 1. ये 2 से 2 cancel. What we get is 1 divided by under root of 2x minus 1. Let's move on to the next rule. Rule number 5. Derivative of sum or difference of two or more functions. Let's say you have a function y is equal to u plus or minus v. It can either be a sum function or a difference function, where u and v are both independently functions of x. Like u could be f of x and v could be g of x. Then dy by dx, the derivative, is equal to du by dx plus or minus, as the case may be, dv by dx. We differentiate both functions u and v separately and then add or subtract, as the case may be, in the final equation. See an example. Y is equal to 3x cube plus 4x square plus 5x minus 3. So when we take the derivative, it becomes dy by dx on the left hand side is equal to 3 into 3x square plus 4 into 2x plus 5. When we simplify, it becomes 9x square plus 8x plus 5. See one more. Y is equal to 7x cube plus 4x square plus 9x plus 3 divided by x. इसमें क्या करेंगे? y is equal to, इस x को, this is a common denominator, so divide this with all of the independent components of this numerator. 7x cube by x plus 4x square by x plus 9x by x plus 3 by x. यहाँ x and x cancel, we get 7x square. Next में plus 4x plus 9 plus 3 by x. Now dy by dx is equal to 7x square को we can write 7 into 2x, right? 7 बाहर आ गया and x square का derivative is 2x. Plus derivative of 4x is 4 plus derivative of constant is 0 plus 3 into क्या है हमारे पास 1 by x. 1 by x can be written as x to the power minus 1 in the numerator. So when we do the derivative of this, what we get is minus 1 here as the coefficient into x to the power minus 1 minus 1. So minus 2. When we simplify it, we get 14x plus 4 minus 3 x to the power minus 2. This x to the power minus 2 comes in the denominator and we get 14x plus 4 minus 3 by x square. Simple. Let's see the next rule now. Rule number 6, which is derivative of the product of two or more functions, also known as product rule. So if y is equal to u into v, where both are functions of x, u and v both are independently functions of x, so we can say u is equal to f of x and v is equal to g of x. Then derivative of y with respect to x is dy by dx is equal to u into dv by dx plus v into du by dx. So what we have done is basically the derivative of y with respect to x is the first function, which is u, into the derivative of the second function plus the second function, that is v, into the derivative of the first function. So this is the rule that we need to use. And if instead of 2 there are 3 functions like y is equal to u into v into w, then you can say dy by dx is equal to u into v into dw by dx plus u into w into dv by dx plus v into w into du by dx. It is like all combinations of products of two functions multiplied with the derivative of the third function. So if you see here, there are 3 functions u, v and w. All 3 are functions of x. So when we write the rule here, what we do is take 2 functions u and v into the derivative of the third function, that is w, plus then again 2 functions u and w, the derivative of the third function v, and plus another combination v into w into the derivative of the first function u. So this is the formula. And it goes on like this if there are more than 3 functions as well. See an example. Say y is equal to x to the power 5 into 2x square plus 1. Now here u is equal to x to the power 5, this is one function of x, and v is equal to 2x square plus 1, and both of these functions are being multiplied. So dy by dx, from the rule what we get is u into dv by dx plus v into du by dx. That is dy by dx is equal to u as it is, that is x5, into d by dx of 2x square plus 1, which is 4x. The derivative of 2x square plus 1 is 4x, plus v as it is, that is 2x square plus 1, into d by dx of x5, which is 5x4. Now I am not explaining the individual derivatives, how I have calculated those. You can go back to the earlier part of this session and understand if you haven't got it fully yet. So solve it and we get 4x to the power 6 plus 10x to the power 6 plus 5x to the power 4. We finally get 14x to the power 6 plus 5x to the power 4. Clear? Now let's come to the last one of the basic rules. इसके बाद जो rules हैं, they are built upon these basic ones only. This rule is called the differentiation of the quotient of two functions, also known as the quotient rule. If y is equal to u divided by v, where u is equal to fx and v is equal to gx. That is, both u and v are independently functions of x, different functions of x. And v is equal to gx is not equal to 0 because v is in the denominator, so it cannot be 0. Then dy by dx is equal to v, that is the function in denominator, into the derivative of numerator function with respect to x, that is du by dx, minus the numerator function, that is u, into the derivative of denominator function with respect to x, that is dv by dx. And all of this divided by v square, that is the square of denominator function. ये देखने में खतरनाक लग रहा है, बट इन रियल इज क्वाइट ईजी. लेट्स सी थ्रू सम एग्जाम्पल्स. y is equal to 8x divided by x cube plus 1. y is equal to 8x divided by x cube plus 1. So here we have two functions, u is 8x and v is x cube plus 1. So using this quotient rule, what we get is the derivative of y with respect to x. We can write dy by dx is equal to v, what is v here, x cube plus 1 into the derivative of numerator. So the derivative of numerator, that is 8x, is 8 into 8 minus u as it is, that is 8x, into the derivative of the denominator, which is 3x square. And all of this divided by the square of the denominator, that is x cube plus 1 whole square. Fine. We can simplify it as 8x cube plus 8 minus 24x cube, all of it divided by x cube plus 1 whole square. Further simplify 8 minus 16x cube divided by x cube plus 1 whole square. Take 8 as common in the numerator, so 8 comes out. 8 into 1 minus 2x cube, all of this divided by x cube plus 1 whole square. So this is the answer. Easy. Let's see another one. Y is equal to x square plus 5x plus 1, whole of this divided by x plus 2. So here the first function u is x square plus 5x plus 1 and the other function is v is x plus 2. So dy by dx, apply the same rule, the quotient rule. V, which is x plus 2 as it is, into the derivative of the numerator. So the derivative of x square plus 5x plus 1 is 2x plus 5 minus numerator as it is into the derivative of x plus 2, which is 1. All of this divided by the square of the denominator, that is x plus 2 whole square. Simplify the equation. 2x square plus 9x plus 10 minus x square and this, and finally we get the answer as x square plus 4x plus 9 divided by x plus 2 whole square. This is the answer. So we'll end this session here. I hope you're finding it easy. We'll solve more questions using all of these rules tomorrow. I'm giving you some questions for practice. Try them on your own. Until then, see you tomorrow. Bye.